Good morning, friends. Welcome to Engineering Works 247. Today we are starting the new subject, which is RCC, Reinforced Cement Concrete. In this video, we will discuss the basic terms regarding the subject, such as first, starting from basics, we can see here the first question is why we only use steel in form of reinforcement. So we can say that strain is equal to change in length upon original length, or we can say delta L upon L. So next term is thermal stresses and strain. Here we can see delta L, or we can see change in length. Change in length is equal to original length into thermal expansion coefficient, and change in temperature. So these are the terms, and here are the basic terms or important terms regarding thermal expansion coefficient of concrete. For concrete, the thermal coefficient of expansion is 11 into 10 raised to minus 6. For steel, it is 12 into 10 raised to minus 6 per degree Celsius. For copper, it is 17 into 10 raised to minus 6. And for aluminium, the coefficient of thermal expansion is 23 into 10 raised to minus 6. So basically, the steel is more preferred in building because it is economical as compared to other material. The steel has high tensile strength, so we can use it in the building. The coefficient of thermal expansion is same or as equal to that of concrete. So the bonding is of steel and concrete, and the thermal expansion of both the material is about the same. And here are the design philosophies of the RCC work, such as first of all it was started on IS 1953, and this first revision of this standard code was made on 1957, which is also known as working stress method. So it is the most traditional method, or we can say the most oldest method which we using. And then this again was revised on 1964, which was named as ultimate load method, or we can say that ULM method. And then again the third revision was done on 1978, and after this revision the name stated it was limit state method. Then again it was revised in 2000. So now we the code using are is IS 456 2000. So here we will discuss about the working stress method and other methods. So first is working stress method, or we can say that WSM method. So for discussing this term, we first know about the stress strain curve for the mild steel, or we can say grade of Fe 250. So here we can say about x-axis there is strain, and on y-axis there is stress. So we can carefully observe the graph. So up to 0 to A it is increasing, or we can say proportionality or elastic limit, and then sudden increase up to B, and after increase in B the graph goes slightly down towards the C, and then up to C to D the strain stress is constant but the strain increases. So and up to D to E, when the curve goes to the point E, we can say it has ultimate stress point. And then E to F, for F we can say fracture point. But according to working stress method, stress in material lies within elastic limit. For example, we can say that there is a block and the load applied on it is 4000 Newton. The stress is 20 Newton per mm square. So stress is equal to force upon area, and while so that area can be calculated using load upon stress. So area here we get is 200 mm square. So conclusion from this is when we increase area, the material consumption increases, which directly affects to the cost, so that it becomes uneconomical to use. So large structures are to be prepared, but due to the structures are large, the stability increases, or stability of the building or any structure increases. For example, we can say that dam, reservoir, water tank, retaining wall, or etc. So here it is stated in Hindi also, if stability is more important as compared to the cost, then this WSM method is used. So it is traditional method in which material strength is underestimated. Next, the heavy and bulk sections are designed. As here we discussed, area is more. So that heavy and bulk sections are designed. So which directly increases the material consumption. So due to high material consumption, it becomes uneconomical method. So more factor of safety for material is used. So factor of safety used for concrete is 3 and in used for steel is 1.78. For direct compression we can use 4. The method is dependent on deterministic approach, or we can say it is based on the theoretical approach. Then second method is the ultimate load method. We can say that it has a ULM method. In this method, this considered the full strength of the materials, which means stress. For here we can see examples such as load applied is on of 4000 Newton. So when we do area, here area is decreased as compared to the working stress method. So while getting conclusion, we can see that area is decreased, so that material consumption also decreases, and due to material consumption decrease, the cost of the building or structure decreases, so that it will be the most economical material. But rather than here we can see the stability and safety also decreases. So this method is rejected due to instability of structure, so that the sections made in this are slender sections, or we can say thin sections. Consider the ultimate strength of member. As member strength, material consumption is too low, so that here we can see the ultimate strength of the member is considered. Design method, it is most economical, so that the material is reduced and the area is reduced, so cost of the material get reduced. So in this method the serviceability criteria is not considered, so we do not use this method. Then next one is limit state method. Nowadays we are using this LSM method only. So the the overall conclusion getting from this method is the structure becomes economical, safe, and stable, so that medium sections are made, so that the sections are not too heavy or too low. We can say that, and it is most widely used method nowadays, or we can say that it is the latest method which we use. In this method, the probabilistic approach is considered. Also considered future loads coming on the structure and design the sections are designed. The method consists of limit state of collapse or strength, and limit state of serviceability. These two factors are considered, which is good. And so that the factor or partial safety factor considered in this is for concrete it is considered 1.5 and for steel it is considered 1.15. The for steel it is low due to the steel is manufactured in a factory so that it is manufactured in a controlled environment so that partial safety factor is low of the steel as compared to the concrete. So thank you. Here we will end the session.